Why are some robot system bugs hard to reproduce? Imagine trying to catch a butterfly that only lands in a certain flower at a specific time of day. Some robot bugs are just like that, tricky to pin down. When robots work in real-world settings, things get complicated fast. And like computer programs that run in predictable environments, robots interact with the physical world, which is full of surprises. Small changes in lighting, surface textures, or nearby objects can make a bug appear or vanish. That unpredictability makes it tough to recreate the exact conditions that cause the issue. Robots have many parts working together, like sensors, motors, and software modules. Sometimes, bugs happen because of how these parts communicate or influence each other. For example, a sensor might give slightly different readings depending on the lighting, causing the robot to make a different decision. These complex interactions are not simple coding errors but subtle issues that only show up under specific circumstances. Reproducing these bugs requires setting up the same environment and system states repeatedly, which can be very hard. Timing also plays a big role. Robots often run several processes at once, like processing sensor data, moving motors, and communicating with other systems. If two processes happen at just the right moment, a bug might occur. But if the timing shifts even slightly, the bug might not show up again. These race conditions are tricky because they depend on the exact sequence and speed of operations, which can vary each time the robot runs. Hardware differences add another layer of difficulty. Even two robots built with the same parts can behave differently over time. Components wear out or respond slightly differently because of manufacturing tolerances. A sensor might drift or a motor might respond slower after some use. These small changes can cause intermittent bugs that are hard to catch because they don't happen consistently. In advanced robotics, especially when biological elements are involved, bugs become even more unpredictable. For example, if a robot uses insects or other biohybrid parts, their responses can vary widely based on environmental stimuli or stimulation levels. These biological responses are not always repeatable, making debugging a real challenge. To tackle these issues, developers create controlled testing environments that mimic real-world conditions as closely as possible. They use systematic analysis to understand when and why bugs happen. Automated testing tools can run many scenarios with slight variations to catch intermittent issues. Logging detailed sensor data helps track what was happening when the bug appeared. Building modular systems allows isolating parts to find the root cause faster. Understanding why some bugs are so hard to reproduce helps engineers improve testing methods. It leads to more reliable robots, especially in learning and prototyping stages where testing and refining are ongoing. The goal is to make robots safer and more dependable, even when their environment and hardware change unexpectedly.